Now that we've learned about the empirical rule, let's go ahead and do some practice with this. So the problem says, suppose that it takes you 20 minutes on average to drive to school with a standard deviation of 2 minutes. You can assume that the commute times are normally distributed. So we're going to start by giving the distribution name. So that's a capital letter N for the normal. And then inside the parentheses, we're going to have two values. The first one is the mean, which is another name for the average. So I have normal with 20. And then my standard deviation is going to be 2. I have normal, 20, and 2. And then I'm actually going to put these numbers along the bottom of my normal curve. So 20 is the mean, which is the center. And then if I go up 1 standard deviation, I'm going to add 2. That gets me to 22. And then I add another 2, so 24, and then another 2, so 26. And then for the ones below, I'm going to subtract 2. So I get 18, 16, and 14. And then our first question here says, what two values border the center 68% of driving times? So that center 68 is plus and minus 1 standard deviation. So 1 standard deviation will be 18 and 22. So 68% of the time, it'll take you between 18 and 22 minutes to make your commute. Which two values border the center 95%? So that center 95% is the 2 standard deviations below and the 2 standard deviations above. So that's going to be the 16 and the 24. So 95% of the time, it's going to take you somewhere between 16 and 24 minutes. Right, how often will you arrive to the school in less than 22 minutes? So picture-wise, here's where 22 is. So less than is going to be all of this area here. So there's a number of different ways we can tackle this. One thing I can tell you right off the bat from looking at this is we know it's got to be bigger than 50. Okay, so here's our center. So we know that that much there is 50. And if that's 50 and that 1 standard deviation up is 34%, we can add 50 plus 34, and that'll give us 84%. You could also look at this and see that it's 16% over here, and we want from here down. So you could take 100% and subtract 16, and that'll give you 84. So there's always a number of different ways to do that. You could add these up all along here. So just quite a few possibilities. How often will you arrive in more than 24 minutes? So here's 24, and that's just this little piece here left in the tail. So this 24 is at the 2 standard deviations mark. And so what's left over here is 2.5%. Right, and then the last one we're looking at between 16 and 22. So now we're looking at just this area. So we already found that from here down is 84%. That was this one here. And we know that this leftover here is 2.5%. So I could take that 84 and subtract 2.5, so that gives me 81.5%. I could look at this and say, okay, this piece is 13.5, and this one's 34, and this one's 34, and I could add all those up. So just there's a number of different ways to get to these a lot of times. All right, so let's take a look at the problem at the next page. This one says the speeds of cars on the highway have a mean of 95 kilometers per hour with a standard deviation of 5 kilometers per hour. So you have a distribution here to put the numbers on and a couple of questions. I'd love for you to go ahead and pause the video and give this a try. All right, so let's go through this together. Let's start with our distribution name. So it does tell us that it's normal, which is a great thing. We can only use these probabilities if we know the distribution is normal. And then we need the mean and the standard deviation. So I have normal, 95, and 5. That gives me the name of my distribution. So I'll put my 95 in the center. And then I'll go by 5. So 100, 105, and 110. Then I'll subtract 5, so 90, 85, and 80. Okay, so first question, what percentage of the cars averaged less than 85? So less than 85, there's 85. So we're looking at this side of the graph here. So this is going to be 2 standard deviations below the mean. So when I'm looking at this one that's 2 standard deviations below the mean, what's left over here is 2.5%. So 2.5% of the cars are going to average less than 85 kilometers per hour. 105. So 105 is up here. We're looking for the average more than 105. So that's going to be this area up here. And oh, look at that. Again, that's also 2 standard deviations. And so by symmetry, we know that this one will also be 2.5%. Okay, if the police car stopped cars that were going more than 105 kilometers, how many cars would they have to stop if there were 8,000 cars on the highway? So we know that 2.5% of the cars are going to drive faster than the 105, and we're going to multiply that by the 8,000. So the one thing to remember here is you have to convert this to a decimal. So that's 0.025. So if I take 8,000 and multiply that out, we're going to get that they're going to expect to pull over about 200 cars here. All right.